Good morning, everyone. In the following, I'll present the result of our analysis of the impact of vegetation distribution, urbanization, and solar radiation on the seasonal variation of the urban heat island in Cebu City using Landsat and global horizontal irradiance data. This is the outline of my presentation. First, I'll give a short introduction about urban heat island effect, its formation mechanism. Then I'll present the study area, methods, results, and I'll end my presentation with conclusions. Now, what is urban heat island effect? Urban heat island, or UHI in short, is a phenomenon in which an urban area is comparatively hotter than the surrounding or adjoining suburban areas or rural areas. To illustrate this effect, shown in the left is the temperature profile of a locality. The urban area is represented by buildings, and the surrounding rural areas are represented by these trees. One can see that there is a bulging of the temperature profile over the urban area. In the right-hand side, in the right-hand figure, is the diurnal evolution or variation of the temperature in one day. So how does UHI come about? To answer that question, we first identify the factors that affect UHI. These factors can be categorized into controllable factors and uncontrollable factors. The controllable factors are natural in origin, such as cloud cover, diurnal conditions, wind speed, season, while the controllable factors are associated or man-made. This can further be categorized into urban design related and population related. The urban design related are building materials, sky view factor, green areas or open spaces. Then the population related are anthropogenic heat emitted by air conditioning units for cooling, and even metabolism of the human body. Air pollutants in the sense that they generate local greenhouse effect. First, when solar radiation hits the environment in the morning, it directly hits the land, the soil, and once the sun rises, the temperature also rises because the land absorbs more heat. However, as shown here, the heat is absorbed by the complex structure of the urban environment. For example, heat will be retained by the urban structure due to the canyon structured environment of the urban area. And in the rural area, as you can see in this figure, there is no complex structure. So heat will not be retained. Whereas here, the absorbed heat will be retained. Then there are also mitigating factors like vegetation. There are more vegetation in the rural areas than in the urban area. And there is also more heat, more water in the rural areas than in urban areas, which mitigate the urban heat island effect in the sense that evaporation is a cooling effect. It extracts energy from, from, the, from the structure. As shown in the figure here, the urban heat island effect is manifested in the evening, and it is because of the retention of heat by the complex structure of the urban area. The intensity of the urban heat island effect depends on the location or the local area. As can be seen in this graph, open spaces will in open spaces the heat absorbed will be will not be retained will be evaporated immediately, while in the closed building structure, the heat will be retained even in the evening, and this UHI will last even at midnight. Our study area is Cebu City. In this map, you can see Cebu City in the central Visayas. In this map, you can see its adjoining municipalities and cities, particularly Mandawi. Cebu City and Mandawi City are highly urbanized. Cebu City and Mandawi City are part of Metro Cebu, which runs from Karkar in the southwest to Danao City in the northwest. Cebu City has 80 barangays. Barangays closer to the coast are more densely populated, and where there are also more development. Elevation is uniform also in the coastal barangays, while there is variation of elevation in the hinterlands, in the rural areas. There is also large variation in solar radiation on the rural barangays at higher elevations, whereas solar radiation is nearly uniform for coastal barangays where urbanization can be found. I now present our methods. In order to quantify the vegetation, we use what is known as the normalized difference vegetation index as a measure of vegetation. This is the formula for the NDVI. And another derivative that has been computed is the NDBI, which means normalized difference built-up index, which is an indicator of land surface modification. The formula for the NDBI is given by this, where SWIR is shortwave infrared reflectance, NIR is near infrared, R is red reflectance. Shown in these maps are the elevation, the NDBI, and the NDBI. For reference, I'm showing in this map the location of Cebu City. As you can see, there is this area near the coast is highly urbanized, whereas the hinterlands, the rural areas of Cebu barangays are sparsely populated. This is the elevation represented by this DEM. As you can see, the coastal barangays are almost flat. The elevation is almost uniform. There is small variation, but higher elevations have high degree of variation. This is the NDVI, which is a measure of vegetation. As you can see, the rural areas are highly vegetated, whereas the urban areas are sparsely vegetated. The NDVI shown in this map indicates the urbanization of the coastal areas or coastal barangays, and there is less urbanization in the hinterlands or the rural barangays. We also consider land surface temperature, and we gather Landsat data since 2014 to 2019. And we also consider legacy Landsat data in order to describe the evolution of the urban heat island in Cebu City. We also consider the global horizontal irradiance, which is a measure of the amount of sunlight incident to a particular area. The horizontal, the GHI for short, is a function of location and solar angle. It is affected by atmospheric conditions, and maps of average daily GHI per month for Cebu City were calculated. In the right, you can see the map for the GHI, which is expressed in watts per square meter for January, April, and August. In the Pag-asa classification of seasons, February, March is considered as cool, dry season. April is dry and hot season, while June, April, May are considered as hot season, hot and dry, while June to December is uh, are considered rainy season. As you can see in the maps, January receives low GHI, April receives high GHI, and this is true for the whole season. Then August has relatively higher GHI. I now present our results. First, we portray the long-term temporal evolution of UHI. For your reference, in the left, I show the map for Metro Cebu, and in the right, I show the land surface temperature from, we selected we selected May 1989, September 2001, and May 2010. And sorry, I cannot see. Now, as you can see, we choose May for summer months for high, I mean for hot season, September for the rainy season, and May for another year, 2010. We compare the extent and the intensity of the UHI, or the land surface temperature. As you can see, there is an increase in the area of the UHI. In 1989, this is Cebu City, then this is Mandawi City. Now, in just 2 years, one can see the growth of the UHI area. This is this area here is the south uh, is the SRP, which is now the flagship project of Cebu City. At that time, this area is not yet well developed, so one can see that the temperature is not so high. In fact, there's no UHI here. Now, in 2010, in May, in summer, take note that the area is now encroached by UHI. And these areas here in the coastal area, the intensity of the UHI effect is high and can be seen to be much higher compared to summer in 1989. So these are the general observations that we have coastal barangays have higher land surface temperature compared to other areas. There is a gradual expansion of the UHI area of the places or areas where land surface temperatures are high. Now, for the 27-year period, we estimate that the UHI area expanded by 0.12 square kilometer per month. Or that is roughly about 12,000, 121,000 meters per square meters per month. We also identified temperature hotspots. This is, we choose IT Park because we can observe that there is development. IT Park is an industrial area, but the buildings are separated from each other and there are open spaces. Now it is surrounded by houses, by residential areas. This is the This is the orthophotograph of the area. These are the temperature maps in January, which is cooler, and April, which is hotter last year. We can identify this area to be hotter compared to the surroundings. Also this area, and this area. So the same thing can be observed in January, but the intensity of the land surface temperature is lower because this is a cooler month. One can see that for areas where houses are close together, one can observe higher temperature. It may be because of the ventilation, because air circulation is limited in this area. Then these areas are residential areas, and somewhere here are also areas where houses are packed together. So one can see that the temperatures of these areas are higher compared to those areas where buildings are quite far apart from each other and there are open spaces and there are vegetation. Now, what one can in the during the pandemic, these areas also have high incidence of the number of cases of COVID-19. And one can see that this, this, these areas coincide with higher temperatures. Although in the literature it is asserted that high temperature can kill the virus, but uh, the, the temperature here is not high enough to kill the virus. And the temperature is also not evenly distributed. So even if we identify these areas as, uh, as having higher temperatures, but there are cold areas here, somewhere here, which may, which may be, which may not, places where virus may not be, the temperature may not be enough to kill them. So there is an explosion of cases in these areas. Barulus is somewhere here. We we read in the newspaper that Barulus was one of the epicenters of COVID-19 cases in Cebu City. Now, we quantify the increase in temperature as the years go by. According to the classification of Pag-asa, which I have already mentioned a while ago, there are three seasons in Cebu City or in Cebu in general: cold dry season, hot dry season, and wet rainy season. As you can see, there is an increase in the temperature throughout the years, even in cold dry season and in also in hot dry season. But the increase for hot dry season is not that high. It is higher in cold dry season, which is also observed in some areas in other countries. Now, in the rainy season, there's no increase in the temperature throughout the years. It may be because of the existence of water, because evaporation, as I have mentioned before, is a cooling process. Then for the seasonal variation of the global horizontal irradiance, one can notice that the spatial variation in the GHI is small regardless of the season. As you can see, the, these variations are quite small. The largest variation occurs in the cool dry months, December to February. Hot dry months, there's a smaller variation, only 4.5. And also in the rainy season, as a whole, the Cebu City gets most of the sunlight in the summer months, which is also, I think, true in other areas. Now here we compare the land surface temperature and the global horizontal irradiance. This is the map of the global horizontal irradiance for representative months of the three seasons. We have January, April, August. This is cooler. This is the hottest. This is in the middle. Now, as you can see, if you compare the land surface temperature, the trend for the temperatures are opposite. This has lower temperature compared to this one, and that can be explained by the presence of water during rainy days, as I have mentioned earlier. So even if there's an increase, there's high solar irradiance, the temperature remains relatively low. So that is all about my presentation, and I'll end up my presentation with some conclusions. The spatial extent of the urban heat island in Cebu City is increasing. The rate is about, if you consider both Mandawi and Cebu City, we choose Mandawi and Cebu City because they are the most urbanized cities in Metro Cebu. It's about 0.12 square kilometer per month since 1989. The average land surface temperature is increasing. The rate of increase is 0.62 degrees Celsius per year since 2002 during cool dry season, and 0.18 degrees Celsius per year during hot season. As I have mentioned before, the rate of increase in summer months is smaller compared to the rate of increase for, for cool dry season. There is no identifiable trend for temperature increase during rainy season. As I have mentioned, this is because of the presence of water during rainy season. Evaporation um, is a is a cooling process. The JHI showed little spatial variation regardless of the season. The largest deviation in the cool dry months of December to February, where average daily JHI is 3.8 kilowatt per square meter, 12.7%, whereas during the hot dry months, the JHI is about 5.4 kilowatt per square meter, and also these other figures. Cebu City gets the most sunlight in the hot month, which is, I think, true for all the areas. So that is the end of my presentation, and I would like to acknowledge Fisher, the University of San Carlos, UP Diliman, and Project GUHeat. And I would like to acknowledge also my former students who did some work who are not anymore part of GUHeat because of some reasons. Luti Scott is our applied physics student. She's now in the Netherlands for her PhD, for her MS in environmental physics. Samantha is still in San Carlos doing her MS. Ronel is working uh, in the industry. So that's the end of my presentation, and thank you very much for your attention.